Right, so with this here, slightly different to the previous question. If you remember with the previous question, we had the log y as the y-axis, okay, plotted against the log x values. Okay, so log y values plotted against the log x values. In this question, it's the second type they could ask. Right? There's two types they could ask. This is the second type where you have the log y values plotted simply against the x values. So this isn't a log x values here, it's just the x values. So it'd be a slightly different approach, but you do the same thing as before. You take log of both sides here, okay, and then you separate these logs here because they times here. It becomes an addition. Same rule then, you bring down that k in front, so you get that. And as I did before, it's useful then to swap these around, okay. And then you look at the format that they want. Now they want it in the form y equals mx plus c. Okay, so of course the that will change to the big Y, yeah, because this is your sort of axes now, isn't it? The logarithmic axes, but it's not going to be a log of x axis here. Okay, as I said, it's going to stay as your x values. So do you know what I'm going to do before I sort of change the format? It might be useful to write it like this, so then you can clearly see it's in the y equals mx plus c format. In other words, you've got this here where your c is your log k and your gradient m is your log b values. The x values are what gets plotted. So the c is your log k, okay, which is, in this case, the constant is 3, isn't it, where it intersects the y-axis. So then you've got log to the base 10 of k equals 3, so you swing the base, so you get then k is 10 cubed, which will be 1000, okay. Now, the gradient will be m, okay, but that, in this case now, is equal to log b, right? I've written it down there, okay. So the gradient value m is what your log b value is on this equation. Okay, so we've got to work out the gradient. Usual approach, y2 minus y1 over x2 minus x1. Okay, so we sub in these values from here. So y2, y1, so 7 minus 3, and then x2, x1, 10 minus 0. But the answer you get, right, which I think comes out to be 4 over 10, which is 2/5, is not just your value that we want for the final answer, it's the value for log b, right, which is your gradient. So we've got to work out b now. Okay, so it doesn't give us b straight away, we've got to work out b, appreciating the fact that this log b is equal to 2/5. So then you swing the base over, so you have 2 then, you have 10 then to the power 2/5. So you get your final answer to be 2.51. So therefore, looking at that format we've got, so we've got 1000, okay, that's what k is, right, and b then is 2.541, so we're going to put a times here, 2.541 then to the power x, so that is your function.